Hello, thanks for coming to my session today, Leveraging Open Source and Hybrid Cloud for zOS, a Rube Goldberg evolution to COTS value. I'm Jim Porell, and I've been working on the mainframe for over 50 years. In the early 1990s, I began focusing on the open source capabilities of IBM's proprietary operating systems, first MVS, then OS 390, and now zOS. That included Unix system services, Open Software Foundation's distributed computing environment, and the introduction of TCP/IP. I mentioned Rube Goldberg only because a lot of these apps can be tried first as proof of concepts, and then if it's successful, can possibly be supported by a vendor or IBM as production-ready code. TCP/IP was a great example of that process. I'm going to spend some time today giving you examples of applications and capabilities that work as both open source or cloud ready that may not have full support behind them. Either way, they can definitely help you solve some very important business problems. Different businesses have different goals for their mainframe. Some businesses just want to get off the mainframe and want to do it as expeditiously as possible. Other businesses plan to keep using it the same way as always, which I call protect their business, but are not really looking to invest tremendously in it. Many businesses believe that the mainframe is a critical component of their IT infrastructure and continue to modernize, enhance, and leverage it for their business value. Regardless of their business perception of the mainframe, open source and cloud technologies can be leveraged in each of these environments to help satisfy their business goals. Many times I hear a customer talk about the cloud versus the mainframe, but I always wondered what their definition of the cloud was. It seems to be everything and sometimes nothing at all. So I took a little bit of time and interviewed some customers to figure out how do they perceive the cloud in their environment. I found there were four major capabilities. One, the end user interface. Let's call it the desktop, the mobile device, or the web browser. It's how those different systems are hosted. They are the system of engagement and provide an end user experience. Next, we have production applications. These are also cloud hosted. Anybody can subscribe to them. These apps provide a particular function. Next, here's the data which those apps operate against. That data can come from a variety of sources. And finally, there's a development environment from which the apps are created and then later hosted into this cloud environment. What's important is each of these are individually provisioned. There's no such thing as all these components in a single operating environment like zOS. The customer might leverage any one of these popular cloud mechanisms like Amazon, IBM Cloud, OpenStack, OpenShift, or Microsoft Azure, but they'll get a cloud instance that does a single task. For scale and disaster recovery, they have multiple cloud instances working in a cluster to meet their service level goals. I'm going to discuss how do these clouds and zOS intersect and use open source technology to bring the two pieces together. It's important to know that the mainframe is not an island. It is blind and deaf and depends on a great system of engagement as the end user interface. An enlightened company will recognize this and find ways for the mainframe, cloud technology, and open systems to collaborate for overall success. Many businesses believe the mainframe is a standalone operation and manage it as a silo, independently of desktops, mobile, and cloud computing servers. This chart shows that any particular mainframe instance could be anywhere on a curve toward collaboration with the cloud. What's important to note is that not all Z systems are legacy systems and avoid this cloud connectivity and open source usage. And not all legacy applications run on System Z. In fact, you can find many running in a desktop environment that inhibits a business's ability to modernize effectively. The crown jewel of the mainframe is its ability to host data, the system of record, as well as provide the transaction processing to update and manage that data. So regardless of a business's intentions, access to that data is a critical success factor. There are two primary ways to do that. One is replication of data or copying it to the cloud. The other is to use data virtualization or in effect, share that data with the cloud. Think about this new data access as a data lake. There's not just one fish in your lake. There are multiple types of data that can be consumed, and those data instances might come from a variety of sources. With replication, data is copied from a source and may be merged with other data to build this lake. It's typically read-only. The lake must have its own security controls and its own replication for high availability and resilience. There's a cost to maintain the data in a timely fashion. On the other hand, data virtualization looks to share data by pulling it down closer to a real-time model. Many times, it can incorporate both updates as well as read-only. It can leverage its existing security controls and existing data resilience for high availability. Data virtualization provides a near real-time latency for accessing the data. As we look at data virtualization, there are three technologies that IBM provides today to facilitate building data lakes. One is the Cloud Pak for Data, which will help maintain copies of data or access to data, but from a cloud-hosted environment. Two is Data Virtualization Manager for zOS, which will leverage the mainframe as the data lake and allow you to collaborate with a variety of sources on the mainframe and other platforms. And three is Datagate, the latest technology to be announced. It uses a high-speed read-only environment for data virtualization and hosting within a cloud environment. Regardless of the technology leveraged, a wide range of systems and non-system Z data can be leveraged. Which offering is best for a given situation? Using an 80-20 rule, it makes sense to host the data where 80% of it originates in the first place. If the bulk of the data being accessed for your lake originates on zOS, then the most economical method of building the data lake would be by leveraging DVM for zOS. The prior couple of charts talked about building the data lake, but now we have to access the data in the lake. Many times, that'll be an analytic application that's trying to garner insight from the data. Again, using the 80-20 rule, if the data is resident on zOS, then you might as well host the applications to do the analytics there as well. Programs like Spark and application programming languages like Python are leveraged regularly to build these analytic applications. There's no reason those applications can't run on zOS and provide faster time to value by operating locally against the resident data. And as mentioned with DVM on the prior charts, non-Z data, such as from Hadoop or other sources, can also be accessed by the same analytic applications using data virtualization capabilities. If you remember the original cloud chart I presented, there were 4 parts. 2 of those parts, the production application and the data lake, can easily be deployed on zOS. We'll get to application development in a bit. Customers have been using tape drives and slower disk drives to back up and manage an archive of data for many, many years. True products have been introduced, the IBM Cloud Tape Connector for zOS and the IBM Advanced Archive for DFSMS or HSM that enable the cloud to be a target for data backup, archive, and migration. These are software-only deployments that are independent of hardware vendor. They're also independent of cloud vendor that can help disaster recovery scenarios speed time to availability over physical tape drives and the need to move those physical devices from one location to another. They are built with security encryption in mind so that the data is protected on every step of the journey. Continuing the journey into security, legacy passwords and user IDs are no longer securely sufficient to meet a wide range of industry and multinational regulations for secure authentication systems. Those regulations mandate multi-factor authentication. MFA is some combination of something you know, something you have, and something you are, aka biometrics. Your user ID and password are something you know, but they would be used in combination with something that you have, like your cell phone, a hardware token, or biometric authentication. The IBM Z MFA offering is capable of interoperating with a wide range of third-party MFA solutions, including those that are cloud-hosted or open source hosted. This chart reflects a couple of those examples. You'll never achieve something like a true single sign-on to all platforms, but you can have a consistent sign-on to the mainframe as well as many other systems with a business's IT infrastructure. And don't be fooled that the deployment of MFA on a desktop alone will protect the mainframe. Any use of user ID and password alone to authenticate to the mainframe is susceptible to insider theft or malicious key logging from those desktop and mobile devices. All users connected to the mainframe have access to critical business information, and as a result, every user should leverage MFA to securely authenticate to their mission-critical applications. There's a lot being done around using open source technology to improve the user experience on the mainframe. Chief among them is the exploitation of ZOE technology by middleware products in the operating system. The overall goal is to reduce the effort to complete tasks, reduce training time, and simplify legacy tasks and experiences. But I'm going to give a couple different examples of using other open source technology to accomplish similar goals in a way that's consistent across the mainframe and other platforms. Let's start by looking at performance analysis and security alert auditing. IBM has a number of products that collect data, process it, and provide alerts. Each of these may have their own dashboards, if you will, whether it's ISPF or web-based for their particular component area. Some, like the IBM Transaction Analysis Workbench or the Omegamon family of products, will process data across multiple subsystems on the mainframe, but they're largely mainframe-centric dashboards. As we discussed earlier, the mainframe is not an island and therefore fits into a larger IT picture. There are a variety of open source and cloud-hosted tools from which those IBM offerings can also make data available for additional diagnostic and alert processing. For example, Splunk is used by many businesses for analytics and against performance metrics, as well as security alerts. All the IBM offerings can make data available in JSON format to be loaded into those tools. Some, like the IMS Performance Analysis tool, can actually stream the JSON format the data directly to those products to get real-time analysis going. The Guardium STAP offerings for IMS DB2 and datasets can also stream data via the Guardium collector into a Splunk dashboard for security purposes. Splunk does not run inside either Linux for System Z or zOS. However, there are several open source software components such as the ELK stack, Elastic, Logstash, Kibana, as well as Grafana that can run on Linux for Z. And because they can run on Linux for Z in a container, they can also run within zOS container extensions on zOS 2.4 and above. Here's a quick demo of the IMS Performance Analysis tool streaming data through the ELK stack to Grafana, where the dashboard can quickly be hosted all within the zOS environment. It can help simplify the entire deployment model for a business and reduce or eliminate the need for a helper cloud app to get that value. So in this particular demo, we're seeing a dashboard that was set up by the end user team and leveraging Grafana as the presentation dashboard, but using the ELK stack to grab that data and be able to present it in a variety of different ways that are way more valuable and understandable than you would if you were to look at this via an ISPF panel. As a consultant, before joining Rocket, I assisted a vendor in porting 56 Amazon Docker containers to Linux on System Z. My ultimate goal was to get these inside zOS. This predated IBM's introduction of ZCX containers in zOS 2.4. I recognized that by co-locating those containers with the middleware of subsystems that they were trying to collaborate with, there would be significant value for this deployment model over a traditional non-Z cloud deployment. For example, disaster recovery and security are already built into the mainframe environment. The performance latency would be better by leveraging hypersockets between the container and the zOS application. The overall cost would be reduced because of the fewer number of physical server images necessary to meet the business needs. Net result, it's the same code in a different container with a superior operations model. This chart is using the specific IMS performance analyzer and its ability to stream JSON formatted data into an analytics application, as well as into other middleware that can help resolve or identify problems from an IBM perspective. As I showed you with the earlier demo, combinations of IBM offered or open source tooling can be leveraged to help diagnose system issues. You'll see in the handout that I provided links to more information about how to put these pieces together yourself within your environment. If anyone has ever done any automation using Rex, CList, or other scripting program, I think you're really going to like Ansible. The Ansible playbooks enable you to work not only on zOS, but with other platforms. The original usage was for development environments, which we'll talk about in a moment, to provision application images. However, it has evolved to be able to handle real production workloads, and IBM is investing to make connectors available to a wide variety of zOS functions so that they can fully participate within an Ansible playbook. I could certainly envision some mainframers with their island hats on that don't want to depend on a non-mainframe implementation of Ansible to choreograph their production operations. There is a version of Ansible available as a Linux container that can run inside zLinux, so the mainframes can be in charge of running their own playbooks. And with Ansible being written in Python, there's no reason a native zOS version can't run as well. However, I'd be hesitant to run a native zOS version of Ansible unless it was zip eligible to reduce software cost. But that container version on Linux can also run within ZCX, again, trying to collapse the overall infrastructure to meet some of your business needs. Saving the best for last, the greatest wealth of open source exists within a modern development environment. As we've learned historically through the IBM Rational brand and now IBM Developer for Z, development belongs on non-mainframes to leverage the value of graphic tooling to generate and edit code. This chart lists a number of open source tools available as is, though many have service agreements for production-ready development environments. Library management, version control, code generation, code editing, provisioning, and testing can be done with a wide range of open source tools that connect and play well with zOS source code. With application development, we understand the importance of source code version control and testing prior to production, but that remains just as important for database code and table definitions. DB2 DevOps Experience was developed to make the database accessible at the speed of developers. Changes to schemas can be understood and choreographed with corresponding application changes. This allows for true continuous integration and continuous development with both transaction programs and DB2 databases. This also meets the needs for database as a service for these developers. DB2 DevOps Experience can work easily with all of the open source tooling identified in the prior chart and any of the IBM offerings. As a result, a business has the flexibility to choose what they feel best meets their business needs while enabling a faster time to market for database changes. Now back where I started. Regardless of a business's desire to either get off the mainframe, stabilize it, or grow with it, open source and cloud technologies can help them speed their desired transitions. Businesses can grow their overall IT skills in a synergistic fashion across platforms. Thanks very much for joining us today. If you have any questions, don't hesitate to ask or reach out to me via the contact information provided for this session. Really appreciate you attending. Bye-bye.